These are a couple of solderless breadboards, one here and another here. These are used for prototyping of electronic circuits, mostly for hobby projects, sometimes for educational purposes, and rarely even large circuits like a computer CPU can be built over breadboards, though it is more difficult, usually only for simple circuits. This is a set of terminal bars. This is another set, and these two are known as bus bars for the ground and positive part of the power supply. These will be bus bars, these are terminal bars, and there is a dovetail connector here and a notch here which can be used for connecting breadboards together. Now you can see that the two breadboards have been connected using those dovetail connectors to form a single larger breadboard. The bus boards are also connected to the terminal board using similar dovetail connectors. So these can also be separated if needed. If you try to make multiple connections and disconnections, the dovetails can break off, as has happened in this case. So you have to be careful. This is the reverse side of the breadboards. You can see that 25 slots on either side are connected together in the bus bar. There is a gap here. Same here also. But in the terminal region, 5 of the holes are connected together. You can see that 5 holes are connected, and there are so many in a column. The columns have been named, even though it may be difficult to read from a video. A, B, C, D, E up to this 5 columns. And this side it is starting from F, and there is a notch here. You can see a notch between the two sets of columns. Here the rows have been numbered starting from the third row only. The first 2 rows have been not included. Towards the end, here it will be 60 here. Suppose a dual inline pin package DIP integrated circuit is mounted here. This will be typically mounted between E and F columns. This one is a 16 pin integrated circuit with 8 pins on either side. So when such a mounting is done, this notch here will be useful to have some air circulation in between. That is, some form of cooling will be provided by air convection by this notch here. That's an advantage of such a mounting. Jumper wires like this can be used for connecting between the terminals. You can see that there are pins at either end which will fit into the spring-loaded holes in the breadboard. There are different colors available. This one is black, this one is red. These two can be used for the power supply. Other colors can be used for different types of circuits. Color coding for a similar circuit can be used. This is a different type of jumper wire. You have pin at one end, and other end is a socket to which you can join another jumper wire with a pin. You can see that another jumper wire with the pin has been joined at the socket. One of the disadvantages of breadboards is that there is some capacitance between the holes, and there could be some inductance when you are running wires here and there. These two will limit the higher end of frequency for which breadboards can be used to below 10 megahertz. Then there could be a contact resistance when you insert the jumper and the pins into the holes, which could be variable also. That will be another disadvantage. Then as these can be plugged out inadvertently, sometimes the circuit can go wrong. I am just illustrating the connection of a capacitor here. This is an electrolytic capacitor. This is the negative terminal and the other one is the positive terminal. If I connect the jumper wire like this, all the points or rather terminals in a row are connected with a metal piece behind. All the holes in a row are connected behind using metal piece. So if I connect a jumper wire here in the same row and connect it to the positive power supply, this power supply will reach the positive part of the capacitor. Suppose I want to connect a resistor parallel to the output of the capacitor, as is sometimes done in an RC filter. You can connect the two ends of the resistor to the same rows as the capacitor is connected. You can see that this is connected to the positive part and this part is connected to the negative. Even though these are connected in different holes, as you can see from here, they will be connected to each other using the metal plate behind these holes. So that is how you build circuits on a breadboard.